Hello dear students. So we are going to learn Tiffeneau-Demjanove rearrangement. So Tiffeneau-Demjanove rearrangement is rearrangement of carbocation. It means in this rearrangement carbocation is reaction intermediate is forming carbocation by diazotization of primary amines leading to the formation of rearranged alcohol. Okay. So first step of this rearrangement is diazotization of primary amines. Okay, so here you can see we have diazotized this primary amine by using HNO2. Instead of HNO2 sometimes we use NaNO2. Okay, which convert our primary amine into N2 nitrogen. Okay, what will happen next? Leading to the formation of rearranged alcohol. It means what? Our final product of this rearrangement reaction is alcohol. Okay, so as we read here, rearrangement reaction of carbocation. So here carbocation is forming. Here you can see how this carbocation is forming. As we know that this N2 is good leaving group, it get removed from here and form carbocation over here, and this carbocation undergo rearrangement. In this rearrangement two products are forming because of stability of carbocation. This carbocation is secondary carbocation. The secondary carbocation is more stable than primary carbocation. Therefore, we get this as a major product. And after ring contraction, we get minor product as this cyclopropyl methyl alcohol. Okay. So why this is minor product? Because we have discussed this cyclopropyl methyl carbocation exists in two conformation. One is bisected conformation and another is perpendicular conformation. Okay, so in perpendicular conformation these MTP orbitals get stability because of shared electron from this carbon and hydrogen sigma bond. Okay, but in bisected conformation this MTP orbital doesn't get electrons, shared pair of electrons from this carbon hydrogen sigma bond. So this is less stable compared to perpendicular conformation. Okay, so because of that this is least stable and gives us minor product, while this is secondary carbocation and gives us major product. Okay, so let us see next example. Okay, so here first step is same. First step is diazotization, conversion of primary amine into N2, which get removed to form a carbocation. Then this carbocation undergo rearrangement. Okay, here we did ring expansion. Okay, this carbon sigma bond shifted towards carbocation. This is 4-membered ring and extending one bond towards this carbocation means 5-membered ring will form. Here you can see, and this carbocation is secondary carbocation. Okay, and this carbocation is primary carbocation. So this will give us minor product and this will give us major product. Here you can see when we add water we get this as a minor product, and when we add water in cyclopropane carbocation we get cyclopentane carbocation we get cyclopentanol as a major product. Okay, so one thing you should keep in your mind that when carbocation is exocyclic means outside the ring, any ring outside the ring there is ring expansion will takes place. When carbocation is outside the ring, ring expansion will takes place, and when carbocation is on the ring, like in our first example here, when carbocation is on the ring, that is endocyclic, then there is ring contraction takes place. Ring contraction means what? It will reduce the size of ring. Okay, ring contraction will takes place in case of carbocation on the ring, and ring expansion will takes place when carbocation is outside the ring. Okay, so depending upon stability we get major and minor product. Okay, let us come to the another example. This is somewhat different example. Okay, in this example we have bicyclic system. So first step is same. There is diazotization to convert our primary amine into N2, which get removed to form a carbocation. Okay, first step is same, but here we have choices for migration, more choices for migration than in previous examples. Okay, here we can migrate this bond or this bond. So I have first migrated this bond from here to here, this carbon carbon sigma bond migrated from there to here towards carbocation. Okay, and we get this structure after ring expansion. Ring expansion will take place and we get this product. This is secondary carbocation, and secondary carbocation gives us this as a major product. While without any rearrangement we get this is primary carbocation. From primary carbocation we get this as a minor product. Sorry, I have forgotten here to write H2O. Here H2O, we have, when we add H2O then only we get alcohol na. So you don't forget to write here H2O. Okay, these are two products. Okay, we have migrated this bond from there to carbocation, and then we get this as a major product. But we have another chance also there. This bond can also shifted towards the carbocation, isn't it? When this carbon carbon sigma bond shifted towards carbocation, then let's see what will happen. So okay, here you can see this carbon carbon sigma bond shifted towards the carbocation. So what will happen? This bond will migrate towards here. It means this carbon which is over here get new, form new carbocation. Okay, so this is secondary carbocation, but still there is again rearrangement takes place. Spontaneous rearrangement takes place. Spontaneous rearrangement takes place on this molecule. Why this spontaneous rearrangement takes place? To convert this carbocation into more stable carbocation. What will happen after migration? This bond migrate towards here. Okay, I have migrated this over here, and because of that this carbon forms a new carbocation. Okay, here you can see new carbocation is formed, which is most stable compared to this secondary carbocation. So how this is more stable? This is in conjugation with this pi bond or double bond. Okay, what will happen because of that? It gets stability, more stability. Okay, this is allylic carbocation and it is most stable compared to this secondary carbocation, and which one after addition of water gives us another major product, this another major product. Okay, so I hope you understand this rearrangement. Try to solve this mechanism, practice it by your own. I have given here some examples so that you understand mechanism and practice mechanism. Here instead of HNO2 I have given here NaNO2. You don't need to write mechanism for diazotization. Focus on mechanism of rearrangement. Okay, so first step is conversion of this NH2 into N2, then N2 will remove, form carbocation over here, N2 will form over here na. So when it removed we get new carbocation over here. That carbocation is primary. Okay, but still we are getting this as a major product and this as a minor product. Why? Because carbocation when form here, it forms a, what it form? It forms a perpendicular conformation of cyclopropane methyl cation. Okay, and because of that, which is more stable, we get this as a major product and not this as a major product. Okay, and after that what we have? Another reaction. This you have to just focus on active site. This all other are just decoration. Don't focus on that. They are not interfering with your reactants on reagent. In reaction condition we have to focus on only our active site where reaction will take place. All others are just decoration. Don't think about that too much. Just focus on our reacting site. Okay, I hope you all understand this rearrangement also. Thank you for watching. Happy learning.